Hello everyone. So here we are going to solve one more question of NEET 2025. Okay, so here is the question. A bob of heavy mass m, here is the bob and its mass is m, is suspended by a light string of length L. Length of the string is L. The bob is given a horizontal velocity v0. Horizontal velocity is v0 as shown in the figure. If the string gets slack at point P, at this point the string becomes slack, okay, making an angle theta. Here is the angle theta from horizontal. The ratio of the speed v of the bob at point P, at this point the speed is v, to the initial speed v0. Initial speed is v0. We will have to find out the ratio of v and v0. Okay, so let us see how we can solve this question. So as we know that if we are going to solve any question of vertical circular motion, it is vertical circular motion. Okay, then we will have to apply two concepts here. First one, equation for centripetal force, and the next one, which is conservation of mechanical energy. Okay, so with the help of these two concepts we can solve any question of vertical circular motion. Okay, so let's apply our first concept, which is for centripetal force. So here first of all let's draw circular path. So that's the circular path, and the particle is somewhere here when the string becomes slack. Okay, and this is the length L. At this point the speed is v, and at this point the tension in the string that becomes 0. Okay, so here we can see that mg force that is acting vertically downward, and this angle is theta here. So we can see that if this angle is theta, then we can say that this tangent and this mg, between these two, the angle that will be theta. Why? Because that is theta, that will be 90 minus theta. So from here we can say that this angle will be theta here. So now we can say that will be mg cos theta, and here this component of mg, that will be mg sin theta. Okay, and as we know that if we say that the centrifugal force which is acting on the particle, that is mv square upon r, and r is L here. So from here we can write that mv square upon L is equal to mg sin theta. Okay, so from here we can get v, that will be m and m cancelled out, Lg sin theta under root. That is our equation number 1. Now we can apply COME, conservation of mechanical energy. Okay, so this is initial point, this is final point. Okay, and here it is v0 speed. So we are taking the reference plane from here. Okay, so let's apply conservation of mechanical energy. So at this point there is kinetic energy half m v0 square. Potential is 0 because the height of the particle is 0 from this plane. Now at this point there is kinetic energy half mv square, and there is some potential energy also, which will be mg and h. H will be L plus, if this is L, that is angle theta, so we can say that this height, that will be L sin theta. That height will be L sin theta. Okay, so total height of this particle from ground, that will be L plus L sin theta. So that will be L plus L sin theta. Okay, so now from here we can see that if we put value of v from equation 1, then we can see that, okay, m is cancelled out here. Okay, now v0 square upon 2 and half v, that will be Lg sin theta, and square is there, so root is removed. Here will be GL and GL sine theta. Okay, now that will be V naught square upon 2 plus, equal to, that will be half Lg sine theta plus Lg sine theta. So there will be 3 by 2 Lg sine theta, okay, and here will be Lg. Solving it, we will get V naught square, that will be 3 Lg sine theta plus 2 Lg. So from here we got Lg, and here will be 3 sine theta plus 1. Okay, so here we got value of V naught. Now that is V and here it is V naught. Okay, 1 minute, here will be 2, there will be 2. That is our equation number 2. Okay, so now from here we can find out V upon V naught. So V upon V naught, that will be Lg sine theta under root, and here will be Lg 3 sine theta plus 2 under root. Lg cancelled out. So V upon V naught, that will be sine theta upon 3 sine theta plus 2 raised to 1 by 2. That will be our answer. So in options we can see that fourth option is the right answer. Here it is sine theta upon 3 sine theta plus 2 root, and here also we can see sine theta upon 2 plus 3 sine theta root. Okay, so that is our answer. I hope you got it. Thank you very much.